Okay, folks, welcome back. Now we're going to talk about the factory design pattern. More specifically, the simple factory idiom. Factory is going to be later on, but this is going to be the foundation for the factory design pattern. If you remember, we're talking about creational design patterns. And the name also gives us a hint, a factory. What do factories do? They manufacture something. In our case, we're going to manufacture objects. So what is the simple factory? Simple factory is a programming idiom or a convention often used approach that provides a simple way to delegate the responsibility of instantiating objects to a factory class. Wow. Beautiful keywords in object-oriented programming, right? So similar to Builder, we're going to take the responsibility of object creation and we're going to put it somewhere else in a different class. In other words, Simple Factory is a class with a method that creates objects. So we're going to have a factory method responsible for creating the objects, creating the instances. When is it useful? When the process of object creation is straightforward. So that's one of the differences comparing with the Builder. Builder is for complex, factory for straightforward object creation process. What are the elements and characteristics we have in Builder in the Simple Factory? So we have a client, so the class that's going to use the factory, the actual factory class responsible for creating the objects, has a method that takes parameters and returns instances of different classes based on those parameters. So we're going to have an option to choose between different conditions. Project interface or a class. An interface or a base class for the objects that the factory creates. So a representation of the base stage or the base product that we want to create in the end. Create concrete product. The actual concrete class that implement or extend the interface or class. Results in the object created by a factory. So concrete product is the actual object we want in the end. Key points, I will go back in a few. Here is the idea of a diagram. So we're going to have a simple restaurant app. Here we have the client as the restaurant class. It's going to have a method order a burger that returns a burger. We care about the burger. We want a burger, but not any type of burger, which is represented by an interface. We want the concrete types. So is it a veggie burger, a beef burger, any different types of burgers? Look that it uses the simple burger factory here to actually instantiate the burger. Let's see it in the code, see if it gives us more meaning. So project is loaded here, simple factory. If we open it up, we have the first restaurant simple factory. Let's take a look at the bad example first. So what is wrong with this piece of code here? Well, first you can tell me it already violates open-close principle. So we have a method, order burger, and you see the if-else condition here. What if we create a new type of burger? We're going to have to come inside this code and modify it, right? So violates open-close principle. But we want to make it more flexible, a little bit more flexible at least. Remember, it's about trade-offs. So how do we restructure this class and make it comply with the simple factory idiom? We create the restaurant class. The order burger doesn't have that terrifying if else anymore. Interesting. But we're gonna go there. So let's go to the main first. What does the main method has? So we are instantiating the restaurant class. From the restaurant, I'm going to order a burger. Which type of burger I want? I specify it here. So I call with the beef, then I call order with the veggie. So if we right click and we run, preparing the beef burger, then we prepare the veggie burger. Interesting. Okay, so let's go to restaurant once again. So the restaurant class is going to have the order burger method. It takes a string so we know which type of burger we want. It's going to return a burger at the end. But we don't have an if else here. Where did our if else go? We introduced the burger factory. So the burger factory is the class responsible for instantiating our different types of burgers. If you saw here on the left, we have the beef burger and the veggie burger. So if we go to the simple burger factory, it looks like the restaurant bad example from the beginning. So we delegated the responsibility of object instantiation to this burger factory class inside the factory method. So this create burger method takes that string that we received from the client. In the end, is going to return a burger. So here we have our if else. It still violates the principle. In the next one, factory method, the official pattern, we're going to see how to address that issue. But if the object creation is a simple step, see, default constructor, there's no arguments here. Sometimes simple factories are used. So if you go to the beef burger, what do we have? Beef burger implementing the burger. Then we have the prepare method. Pretend that there's some logic here for preparing a burger. Same idea for the veggie burger. So the veggie burger implements burger. The prepare method has to be implemented, some logic for preparing the veggie burger, and it gives us the result. So from our factory class, notice that we assigned the instance to the burger variable we have here, and in the end we return that object. If we go to try this and correlate, what happened here? So the restaurant class is our client, the one that is going to invoke order burger method that actually goes to the simple burger factory. So if we go again to restaurant, what do we have? Restaurant uses the simple burger factory. Simple burger factory. The simple burger factory invokes the create burger method. So there's a create burger method here. That factory, when we go to the create burger, it of course has to specify, okay, which type of burger do you want? So we're passing it here in the argument list. So if you go to that method, it takes us to create burger. So simple burger factory, create the burger. It's gonna have a reference to the interface type. Reference to the interface type. And then you choose, well, you already chose, right? In the string parameter, you choose what type of burger, which type of class you would like to be created. So if it's a beef, create a beef burger. Create the beef burger. If it's veggie, we create the veggie burger. So the simple burger factory makes use of those concrete products. So those are the concrete products. Back to simple factory, all is good. Let's see another example. See if we can correlate. Oh, so this one, close everything. Toothpaste factory. So to the toothpaste factory, what do we have here? Right click and run. What do we have? Brushing teeth with mint flavored toothpaste, then herbal, then whitening. So what are the steps happening here? So first, we're instantiating our toothpaste factory. Notice it's slightly different than the restaurant, but the concept is the same. Sometimes you're going to have them separately. So here we have simple toothpaste factory. We instantiate that factory. If you go to the factory, this factory is the direct step for creating those instances. See? So here we have the create toothpaste method. It's going to return a toothpaste class reference. Takes the string type, so we can actually provide a switch and knows which type we want. So if it's mint, instantiate mint. If it's herbal, instantiate herbal. Whitening, instantiate whitening. If it's none of those, gives us an exception. So create the reference to toothpaste factory. Then we're going to assign our variables. So from the toothpaste factory, I'm going to invoke the create toothpaste method, pass with the argument. You can note that this is the static method, so we could call it directly from the class reference. Here we're instantiating just for demo purposes, but we could call directly from the class. And then rinse and repeat for the different types of toothpaste that we have. So okay, this is the steps for creating the instances of the products, creating the instances of the class that we want. But then, what do you want to do with that class? So for toothpaste, if you go to toothpaste, it's an interface with the method brush teeth. Okay. If you explore each class, concrete one, herbal flavored toothpaste implements toothpaste. So you do have to provide an implementation for that method specific for each type of toothpaste. So from each instance, I'm just invoking the brush teeth method. So from mint, I invoke the method on that object we just generated. So mint toothpaste.brush teeth gives me the mint flavored. Then the herbal gives me herbal. Whitening gives me whitening. So far so good? Hopefully so. So let's go to the other example. You might notice an issue. It's red here. So if you go to right click, let's see if this one has the solve problems. It doesn't give us that. So if you copy the code for the G7 example, you might have issues. If you do, you can go to where is it? Right click, go to properties, then we can go to libraries, change your JDK version. If you're using 17, it should be okay. If you're using this 1.8, that's why we're having issues. So if I'm not mistaken, starting from 17, we're good to go. I have 18, so I pick Java Platform 18, hit OK, and our code is good to run. So if we go to Simple Factory example, one more, what do we have here? Right click, run the file. Expand this a little bit. So here we have get all G7 countries as a list. Then we have Canada, France, Germany, Italy. It prints out a bunch of countries. So first it prints as a list, then it prints as a set. Then get Canada by name from the list, returns only Canada. Okay, let's see what happens. So first one, get all G7 countries as a list. There you go. So here we have create G7 country. Okay, so it's a class right here. We invoke the method get G7 country collection, and we pass an argument. So and then the result from that class, we invoke the method get all G7. Let's take a look. So create G7 country. If we go there, look at this. Looks like a factory class. So we have the method G7 country collection, G7 country collection. That's the method we called. So from that class is a static method, so we're directly invoking get G7 country collection. We have to give the type. So we want it as a list. So from a list, so case list, return a new instance of that class we want. So we want G7 country list. So it's gonna return this class. Let's go there. This class implements one interface. Ooh, notice how the pattern establishes here? It's just repeating with a different type of situation. Just a list of countries now. So from that class, we have a list of those G7 countries. You can see here, list of strings. We're initializing arrays as list with all those strings. Then we have a method for getting all the G7 countries, returning a list. This is the method. Then we also have a get country by name. You pass the name, because if you want to get it by name, you have to give the name. Here's a temporary list, looping through the G7 list at the top. So go one by one and you're comparing to the name that you're passing. If it matches, we're going to add to the list, to the temporary list, and we're returning the temporary list. So just different logic of what it's doing in the method. But the pattern is established. There you go. So what do we have here? Then we have get all G7 countries as a set. Same idea. Create G7 country, create G7 country. Get country collection is the same method, right? The same factory method. But this time we're going to call it as a set. So from the set, create a new instance of G7 country set. This class, country set, also implements the same interface. And this is a little bit different. Notice that the other one was a list. This one is a set of strings. And get all the G7 countries. Same idea. This one is duplicating it. Makes a copy and create what? Create the set based on the list. So from that class, G7 country list, give me the countries, but this is going to create a copy of it as a set. Similarly, the get country by name for the set class, it's going to return a set in the end. So from the G country list, we instantiate it, we get the country by name, give it a name, and we return this copy of method. It's going to return it as a set. Let's see if this, yeah, we can see it, yeah. So it does return as a set. This is internal Java classes. We don't need to go there at this moment. So the factory class and the factory methods are represented by this beautiful structure. Violates open closed, because if we create a new type, we have to come to this class and change it. So we're going to address it in the future videos. I haven't gone through the last example, so I expect you to go through it on your own. It's just the exact same thing, but we're just invoking a different method from the product class, from the actual class we want to instantiate. Okay? So key points from the Simple Factory allows a centralized control over the creation of objects. So the creation steps are in one class, in one method. It provides a clear separation between the client code and the actual object creation logic. When is it used? When the creation steps are simple, typically when there's no arguments or it's a very simple constructor process. Helps with a single responsibility because we're separating the concerns, we're separating the responsibilities. Each class is responsible for one thing, but it violates the open-close principle because every time we have to add a new construction step, we have to go to the code, open it, and change it. That was all, and that sets up the base for the next official pattern, which is the factory method. I'll stay here. Thank you so much. Let me know if you have any questions.